I'm curious about the Go. Okay, first, hello everyone. Welcome to another session of All Things Go, where we talk about many things related to Golang's tools, but in a really a strong favor of blockchains and especially Cardano. In the past couple of meetings, we were looking into some of the fundamentals, concepts, I and primitives of the whole blockchain. For example, time or protocol parameters, fees. How times works, and and also the tools that use these primitives or these fundamental things and how they are utilizing those. Now we should maybe be careful about using them. And then we kind of wanted to look into some code bases, but as Chris and other members suggested that let's actually again going back to those fundamentals and as we are seeing here, I mean, by the way, I've added here and audience kind of disagree with looking into this because, well, it's fairly new, it's under development, never tested, and so, yeah, but definitely we can talk about some of this stuff, like what does Pultus version 3 means, like what was the version 1, and now we have V3, and then these following agenda suggested, look into transactions, blocks, and of course CBOR, although we talked a little bit about that in previous sessions. And answering this question as well, what are the production-ready tools in our disposal? Sorry, at our disposal. By production-ready means that although those tools are under development for getting the new features, but at least they have a stable version or major release that we can use and build our stuff there. And once again there is this another major release or stable version, we can update or upgrade our product or project as well. So I hope we can cover all of that, but I think it's a pretty good agenda. But I just, before the starting the recording, I was reading Era's message in the chat, and he said, I'm curious about Go. I don't know much about Go, and I'm curious to see why Go is being used in Cardano land with some concrete example and tools showcase. Sure. And Chris, I guess, added, responded, or maybe, I don't know. Uh, but Chris said, Go currently is mostly used in the ecosystem to build infrastructure software. Yeah. It's used for backend service such as transaction building for text hunters, which use Apollo, or webhook creation using Adder. And I would love to, I don't know, today or something, when another day, looking into Adder as well. But yeah, so based on this stuff, let's look into the transaction. Well, let me show you a transaction that I was dealing with. I just want to show you, maybe I have, yeah. So, uh, well, just in a very dirty and high level, if you see a transaction in Cardano, it should look like this, like bunch of numbers and letters, which, yeah, maybe doesn't make sense at all. But this is something we call CBOR. We will look into it, like what is like this is encoded CBOR. Like, well, why CBOR? What is CBOR? Nobody will look into it. And once you deserialize or decrypt, kind of, I mean, it's not encryption, but still, we convert that to human readable. We will end up with something like this. See, that's just I converted that with a tool called Seaboard Arc. It is a tool written in Rust. Uh, I don't know about a Golang tool, like a CLI tool to do that. Maybe there are, but this is pretty, just simple and easy to use. So if we deserialize this guy, we will end up with something like that. And as we see, it is look like a JSON object with bunch of, uh, inner object or inner list and, bunch of again numbers and hashes, which definitely doesn't make sense at all. So I think here again we should look in a place that I mean, I think 2 weeks ago talk about, uh, which was CDDL. CDDL would be a document, would be a place that kind of explain uh, what would be these numbers, like either 0, 1 here or here 2, 3, their position, like what should come here. And let me find that. Uh, I think it would be Cardano Ledger. Uh, the we think wait, is it Cardano Ledger? Yeah, Cardano Ledger, and I think errors, and in the errors, am I which is Conway, and then IMPO and CDDLs. To be honest, I don't know what these CDDL stand for. Let me show CDDL. Definitely doesn't have anything for recycling. Probably it's common. Is it common development distribution? No.
Concise data definition language. Scroll down. It's the IETF one. Outside, the first one passed all the ads.
Okay. Okay. Concise, this is the guy. So, concise data definition language. Okay. So, well, I think it's explanatory enough. That's like, what does this mean? Like, we kind of state bunch of uh, data, bunch of, as we say, a representation. I mean, here again, Seaborn, again, we saw it. And as we can see, Seaborn means concise binary object representation. So, yeah, so probably, yeah, let me actually look into this of RFC. This is quite interesting. Um, and if you don't know what is RFC, well, RFC is basically the standards of the whole internet. I mean, if I can say it in very uh, maybe bad way. So there's this organization. I mean, we have Internet Engineering Task Force. They are kind of the people behind the standardization of the things happening in internet, like the protocols, data queries, like how these internet like connection of these things, objects, I don't know, anything existing that they want to be connected to each other should talk to each other. So it's like bunch of languages, syntaxes, and other stuff. And they release if there is something new, they release it through RFC, and they just assign number to it so we can know like what is it. And here we can see that, yeah, this is RFC about CDDL. What is it? A notational convention to express CBOR, concise binary object representation, and JSON data structure. So we have this binary representation. So we have a bunch of data. If I'm, by the way, please correct me. We have a data. We want to send this data to someone else. We want to send them in a binary way. Why? Because it's faster, it's easier, computer understand binary better than anything else. So it's probably lighter, more performant, everything. Like it's binary. It's the lowest you can go with sending a data to from a place to another place. And then the CDDL is kind of an explanation or definition of that object. So if you want to build that object, or if you want to, as I said here, like I show you here, understand this object. But this is the seaboard. Sure, we deserialize that. And now we have this, and if we want to understand it, like their position, the two, like what should be here, we need this CDDL. And how do we, well, okay, so there are a lot of things, which probably, if I can find that table, I don't know if it would be here, but let's look into the CDDL here, just to see the CDDL of that. So this file was auto-generated. Please not modify. Okay. So even this file wasn't generated by hand. Like someone didn't wrote that. It was auto-generated by Hoodle. I don't know what is it. Probably a tool to build CDDL. To just tell to this tool to what is it, all of these. And we have block transaction KES signature, which we talk about. If you guys remember, it's related to pools and the whole signatory of the pool operators. Languages, which if you don't know, like Puritus is the smart contract. Probably they're talking about this language. They don't talk about like English or I don't know French or Spanish. And potential languages signing keys. So yeah, I mean if we just looking into that. And then there are other definition, hash, and probably just the size. And I just want to reach to the transaction place, like a place that explain about the transaction, but probably we will pass other stuff too. Like here talks about the address. So if you see a Cardano address, let me bring my wallet so that we can see a bunch of addresses. It's explain like what that address should look like. Like so here we have an address here. Zoom in. And again, this address is encoded of something else, a bunch of stuff. Okay, encoded of what exactly? Here we can see it. And then reward address, Byron addresses, and here is most likely it's the binary representation of that address, receiver, and asset name probably talks about the whole, tokens, auxiliary data, metadata. Metadata is another object or JSON object we can say which will be attached to transaction. It's like more information, like add-on or I don't know, extra information about the transaction. You can talk about many things inside it, like if there is a token, if there is some other stuff. You can send even a message if you want to send something, if you want to record a message, I don't know, happy birthday in that transaction. This is the place. But the thing is, the metadata will not be engaged in the smart contract and stuff. So we'll talk about that. Like there are information which we a smart contract uses like datum or redeemer. There are information it doesn't, which is like metadata. But we can see a bunch of like you see that we have Protus version 1, 2, 3. We have native script. We have several version of a smart contract. If we can say, well, native script. I don't know if we can call it a smart contract, but if you guys remember, we talk about what is a smart contract, and I can say again, remind We have wallets. Like maybe hopefully I hope that you guys know what is wallet. Wallet will be a place that holds values, whether it's token, ADA, NFT, anything, anything that is on chains, blockchain. You hold that in that wallet. And a smart contract or these scripts, which they call scripts, are same thing. It is another form of wallet, but a normal wallet, which we saw these addresses, like for those wallets, like here we saw it, they are just again a code that holds, like for example, these transactions, these UTXOs, token, etc. But you manage that. A human manage that. By human, I mean there is a signing key, there is a private key, like for example, if I want to send something, let me, like for example, sending a bunch of things to myself, I don't know, like 200 ADA. And if I want to say, I have to sign it, right? This is, there is a signing. Like me as a human, as an owner, I should prove that I own or I have the control or ownership of this wallet or these code inside these packets. This just imagine like I own that. But in the smart contract, everything is exactly the same. But this signature signing, it's going to happen with a validation. So it's like a function, and if that function returns true, okay, it's like a sign. Like if I just sign here, basically it's a binary situation. If I sign it with correct password, well, thing is true, no problem, green. And if I sign it with bad password or wrong password or something else, it just says false. And so absolutely two situations. There are not third situation, true or false. True signatory or accepted, uh, false not. Same thing with the smart contract. We have a situation with this script that if there is this function, and inside that function can be many things. It's not the topic of here, but imagine there is a function, and if that function, the output, or if that function works, and if that function doesn't return error, it just works fine without problem, it returns true, and it executed without any issue, that means that you can spend those values, those tokens, those ADA, those NFT, anything inside that programmatically, wallet, kind of we can say, and that's it. So a code, a program is going to decide that you or anyone can spend or touch those values, those things inside that address. And if it fails, if that function fails for any reason, I mean, again, we don't want to go into the depth of that. But if that function fails, it means that same thing here with this, the signatory. You cannot spend it. You cannot touch those values. It's just you failed, or whomever wanted to touch those stuff inside it failed. Or what are those stuff? Well, there are UTXOs, as we can see, there are tokens. We can talk about that, sure, but that's basically so. A script is again a wallet that doesn't need signing like a normal wallet. Is just a function that needs to be executed successfully. And if it was successfully executed without an issue, well, we can spend whatever inside. So the scripts or small contracts or whatever they call that, they have addresses. They're same with a wallet. But according to this CDDL, as we just saw, their address is a little bit different so that we can identify, okay, this is a normal wallet, human wallets, This is a smart contract. Okay, what is it? Native script, previous version 3, etc. So that's a whole difference between a wallet, a normal wallet, and a smart contract. Things are a little bit, or maybe in some other blockchain, are too much different. So what I just said is just think about it. It is uh, just Cardano, no any other blockchain. Things are a little bit different in, I mean, actually not that much. I mean, now it's really different in Ethereum or account-based blockchain or any other blockchain that you've heard of, even Bitcoin. So in, for example, Bitcoin, we don't have a smart contract. We don't have those functions. There we have just wallets. So if there is a Bitcoin, you just can spend or touch those values or Bitcoins with just signing or not signing. That too binary. But here, no, we have a smart contract, and that's a whole extended. I mean, if you heard, like we Cardano is extension of the Bitcoin. We use Bitcoin, and maybe you have heard that. The whole idea is that we uh, optimized, or we evolved the whole Bitcoin blockchain or ideas and the fundamental, and added other stuff. For example, put it as a smart contract, or the script, wallet, which human doesn't need, to run it. It's a bunch of code. Anyway, so let's look into other stuff, and let me look into the chat as well and see. Do I need to? Right. It's really good. Okay, links to this. Yeah, thank you, Scott, for the CDL. Sorry, I should have put this link as well. And we see that valid blocks must be satisfied following to constraint. Well, so if a node, or if you want to build a node with another language or whatever, if you just want to be part of this whole network and add a block, a verified block, you should follow these two. Probably that would be a valid blocks must also satisfy the following two constraint. Because it use also, probably there are other constraint or other stuff, but yeah, the length of transaction bodies and transaction witnesses set must be the same, and the transaction index must be strictly smaller than the length of transaction bodies. Well, um, I have no comments. I just want to say about I mean, we'll talk about transaction witness and body. By the way, about the body, well, this is the body. The whole thing from the top to bottom is the body of that transaction, or this cyborg guy we just deserialized, or um, sorry. So what witnesses? Witnesses are those signatories, right? Like here, just so. So if you want to sign something, you are going to create a transaction. Just saw it. Let me get. Oh shit. So if I just want to send someone bunch of things, this is a transaction. I'm going to create a transaction. This is a transaction ID, transaction size, the fee, whatever. And if I sign it, I mean, I have to sign it. But I mean, right now there is a transaction. We call it unsigned transaction. So we can have a transaction here. We can have a transaction body here, but without any signature. But if I sign that, my signature will be added to a place called transaction witness. And here is the place. This is you see this part is for that transaction witness. The whole thing again is transaction body, but here is transaction witness. What the hell is this thing? We'll talk about it later. Anyway, like what should be. But just remember, transaction witness is kind of like if we say that transaction body, like the transaction consists of maybe several parts. One is the witness, which is the signatories, they show that they are the owner of these values or whatever. And the other stuff, which we see here, and hopefully we reach to that level very soon. But what are those other stuff? Uh, is this the one? No. Certificate, committee, constitution, cost model. This these are again related to mostly those smart contracts. Certificate is related to rewarding the whole staking stuff, and the committee constitution, governance. Let's not talk about cost model. That function we talk about here is not free. Like if your function is big, well, the people have to pay more money for that function to be executed. And if that function is a smaller, right? So that's reasonable or logical. And who's going to get that fee? Well, again, the blockchain or the treasury or something. But these people who are running the nodes, who are running these Cardano, they're under their shoulder, they are going to compute this function again, running and running again and that. So it shouldn't be free, you know. So here is the place that's calculate that, like how much that function should cost. And then, well, let's go with DNS. Interesting. Okay. What is DNS name? Do you know this, Chris? DNS name in CDDL? I've seen it first time.
Yeah, it's part of Relay.
Oh, okay. For this for node. So epoch, it's execution. EX units. This is the price. Execution unit. Execution price. This is again related to that function, aka a smart contract, aka a script, whatever. If you heard all of these terms. The units means like how much memory it takes that function, how much CPU. We call it here steps. How much CPU, and then let's not talk about the numbers, but that's it. That function needs only two things: a memory, RAM. I mean, like your computer for running any program, and CPU. And here we call it a steps for the CPU and memory for the RAM. Like maybe that function needs to go to the RAM, or I don't know, to some place to just run. If it is big function, whatever. And both of them have uint, I think, or unit. Is it? Yeah. Here is sorry. Maybe it's ex units, but here is uint. So it's again, it's integer, but it can go, it's a big integer and protocol parameter. Maybe we can look into it. But anyway, all these units are costly. How much? Yeah, we can go and talk about it. But again, those units are costly, so these numbers matters. And if I just want to show you very quick, fast, like how does it look like in a transaction? Let me a little bit zooming. This is it. See that? Like this is a inside. Like again, doesn't make sense at all. A bunch of numbers, whatever. And that's the whole point, right? Like just computers should understand this, and the humans with help should understand that. But after look into the all this CDL, you can. What this is that two number we were talking about. So you see, that's a bunch of big numbers, not small numbers. And then take care. Here is well, I think it is a blog. It talks about blogs, header body signature, block numbers, slot, previous issuer, verification, block, body size, hash, pressure, Portugal. I think this is all about the body of the block of a blockchain. Then probably this is again related to nodes, native scripts. I just want to, sorry, going to really faster to reach the transaction place, which is Uh, I don't think this is the transaction again. Here it is. Am I right? No, it is not. Sorry. Where is the transaction? We talk about transaction. Group hash. Transaction body. Yeah, yeah. So we see a transaction. I mean, if we call it a transaction, it consists of several things. A transaction body, transaction witness set, Boolean, and auxiliary data. And auxiliary data besides metadata. So this is it. It's a Boolean, and I don't remember what is it. I mean, we will look into it. This is, I think, it's a metadata, witness set, and a transaction body. So, so now we kind of make sense of these parts, kind of, you can say, and we can see like this is an object, like with these curly bracket, we can say, okay, these are different. Sure, it's kind of pretty looking JSON, but anyway, curly bracket says that it is a new object, separate, but these are not, these are inside this object. So we have one object here, we have two object, we have another one which is true and null because we don't have auxiliary data or aka metadata. No, we don't want to attach any other data here. But yeah, that's the body. I mean, sorry, not the body. Apparently, I used the wrong language. The transaction, let's say the transaction CBOR. A transaction CBOR, this guy it's really, I mean, doesn't make sense. If we deserializer, the decrypted kind of would be these things, which transaction body is different. So let's not call it transaction CBOR. And that transaction body, which we saw, it consists of these numbers. Okay, what are these numbers? We see that, for example, transaction so input, so transaction outputs. By transaction input, transaction output, I mean, by we here meant UTXOs. So here, if we look to this example, we have this zero and we have these one. So in any transaction, there are these two parts, right? Hence the name transaction. Right? There is a transforming or transportation, and we call it that. Of course, it's the action because we are just we are working. We do a work, and that work must always have a two party. One is input, another is output. Uh, Origin and then a destination, a place to start, place to end. So inputs, outputs. We put as an input bunch of values, bunch of things that we want to spend. We want to do something with them. We want to touch them. In case of Cardano IDO, whatever. And here is the output. We did something on them. We increased them, decreased them. I don't know. We did something on them, and that would be the output. So how do we know? Right here, it has started with zero. These are the inputs. One, these are the outputs. We can see it's a list until reach two. So this is the list, and inside that, again, there is this one and two. These are the index of those UTXOs or those two. For example, we want to, we have a big like we have 10,000 ADA and we want to divide it by two, 5,000. So let's say this is the 10,000 ADA as an input divided by 5,000. 5,000 to my wallet, to myself, 5,000 to Chris or James or whomever. So that's why we have two output. But here we have three. As we can see, the index start at zero. Um, Let's look to other things. And a slot number would be the three. A slot number, if you guys remember, it talks about the time. So we kind of say, talk about the time here, the transaction. Where is the time? Here. So what we see here actually is a time. It's this, I mean, it's a time on the blockchain. And if you guys remember, we kind of say that we have epoch and we have a slot. And in the sense of, I mean, the traditional understanding, epoch is kind of a day, and slots are those seconds or, the hours. So 24 hours, each 24 hours, we have a day. We just move forward, increment that day from one to two, or, just doing that. And kind of reset that. So this is kind of exactly the same. Epoch in the blockchain is the same kind of day. So, but the slot is those hours. So after each epoch, these slot will reset. They start from zero till 432,000, which is the length of the day in blockchain, in Cardano at least. And it can be changed, by the way. So it can be increased or decreased. We saw, I mean, the previous session. The, it was different, but now it's 1 second. The we have two slot numbers. I don't know why exactly. Like what would be the difference between two? Let me see. Do we have something like that here? Like why do we eight? So we have three, and we don't have eight. So here we have three. We don't have eight. I don't know why we have two slot number.
Mix, isn't that because you have an interval on chain?
Oh, so this is the like the current time, and this is the time that, for example,
And yeah, I think one, yeah, exactly. So I
so
think
yeah, that's from
the
validity.
first slot number
TTL.
defines after which a transaction is valid, and the other one would be
Hmm.
before it is valid.
I see. Yeah, Chris, sorry, you were saying something?
Same thing as Adrian. Yeah, it's the
Okay.
TTL.
Yeah. So again, TTL is the time to leave. So let's say that you build this transaction. I mean, let's imagine this is the now time. Like exactly now, and then maybe you want to like right now this transaction can be submitted to this blockchain or can be part of a block at any time. We don't care. No one cares here because the code doesn't care here. We never mentioned something, so it is valid. Before this time, we cannot put that because this is a starting up. We can say, hey, this transaction was built now. So before this time, you cannot put it. If the transaction doesn't make sense, it's like you just put a time, an expiration date, issue date, something like that. So this is, as I understood now, and Adrian and Chris said, let's say this is issue time, and this is expiration time for your transaction. If you have issue time and no expiration time, it means that this transaction after the issue time is valid, it's working, there is no problem for eternity. If the issue time is now, for example. But if the transaction has issue time and expiration time, well, it shows that this transaction should be submitted within that period. Like you cannot like it's like it's like let's say it's ice cream. I don't know. It's bread or something. You have to use that within that period. If you use that after that period, well, it is not good. And if a transaction doesn't have issue time, but it has expiration time, it shows that you can submit that transaction before this expiration anytime. So there is this uh, period that you can dictate to your transaction that when this transaction is valid or when we can submit it, like when this transaction is going to be part of the blockchain or part of those blocks that we were talking about. And based on, just by playing with this issue time and expiration time, which, I mean, we have different names, like technical term, invalid hereafter, it's just something like that. I just don't care about that right now. But this is the issue time and expiration time. You can just, make your transaction more deterministic. Let me show you here something. Like here we can see that there is something here. This transaction is valid. You see that the pop-up says transaction will be executed eventually or become invalid if an input UTXO was consumed by a different transaction. So you see this transaction, what is it? A transaction with issue time or expiration time. Uh, that input might be consumed by someone else or in another transaction or another program or another things or another smart contract. The owner they can decide to whomever. So these time are really important because uh, if the times are right, no problem, issue time, expiration time. But these inputs are not valid. Well, we can say here's as it say, it's invalid because I can just stay in this situation and open another, like for example, another wallet, or someone else has my wallet as well, and try to send exactly same amount. And let's assume that my input, like here, are same. This is important. Let's assume I'm using one UTXO, one input, one value. I mean, I have just one. That's all. And here, if I do something and submit it, sure, it works, but this absolutely it shouldn't. It mustn't. If it works, well, the whole fundamental of blockchain is, I mean, it just violated. Like, so that's it. Like double spending or quote unquote. That's the whole idea. So how long you can use a UTXO, how long you can use an input to build your output, whatever, again, it's bunch of times. So even you are sending something with your wallets, there is no smart contract, there is no function, all these things. Still, the time is important. And we'll talk about like more playing with time later, but yeah, this is it. And as you can see, it's unsigned. So we have a transaction body. So here at that stage, behind the scene, actually, I can download. You see that I can download unsigned. I have this object. I have a transaction body, but I don't have a witness. This transaction body wasn't signed. And the blockchain Cardano doesn't accept a transaction without witness. They don't. Someone should be like if you are spending my money, I should approve it, right? So the blockchain doesn't accept it. But this is the body. It's like let's say it's a contract with bunch of articles and closure and stuff. And it's piece of paper without my signature. And this is the signature. And blockchain accepted only and only if I sign it. So that's the whole idea here. Kind of see there is this body and the witness. And it can be many people, by the way. Like two, three inputs from three wallets, three different wallets, or you make a situation that several people must sign, 10 people, imagine. All of them must sign. So it's like a contract, right? So, and well, hence kind of the name, a smart contract. But anyway, uh, yeah, these are the places. Although, thank you, Adrian and Chris, for explaining that. I wonder, did they explain that somewhere about these two slot numbers or not? So yeah, it's not really extraordinary or definite. We don't have definition, but that's it. And then certificates. Certificates related to, staking mostly. Like if you want to stake your wallet to somewhere, pool or whatever to reward, we'll talk about the whole reward. And that's a really fundamental thing in Cardano. It needs probably even several sessions for itself. What that is staking, rewards, whatever. And of course, of withdrawals. But if you get the reward, you should be able to withdraw. So yeah, that's a place. But yeah, let's leave them alone. But again, these two are, and you can of course go research for yourself. And auxiliary data hash. If most likely if I have a, I mean, I'm just assuming, if I have a metadata, this guy auxiliary data, this would be the hash. So the transaction body says that, there is this guy coming with me in this transaction, and I want to know that, yeah, this is the guy inside this transaction. Like I should kind of say like I'm traveling with this person. Well, how do I know this person is legit? This is the same data I'm, traveling with. Well, a hash. A hash of this data will be added to the body. Then the mint. Well, if you mint a token or something. By minting, you are creating a token. I mean, how more fundamental I can say about token and minting. Well, can anyone help? Um, let's say, like, let me show you in the wallet. So you see that I wanted to send 200 ADA. Like we have 2,295 ADA. And I wanted to send that to this. And here is the wallet method. You can build this with the Apollo or transaction or any other Golang tool or any other language tool. So the fundamental is, yeah, this is the input, this is the output. But if you see these 200, the 2000, these are values, right? Like now it worth a bunch of dollar, like each worth, let's say $1. So what do we call these things? We don't call them dollars. We don't call them dollar bills. They are not fiat. They are not, but we call them cryptocurrencies. So these cryptocurrencies, like the digital currencies, or all these terms, are what we call tokens as well. But the other name of these cryptocurrencies are tokens. Well, why do we call them tokens? Long story, but anyway. So ADA itself, which is the native quote unquote token of or coin of the Cardano, is again a token. But you have the ability, and by you, I mean whoever wants to, do this exactly, to create new tokens. Same exactly like ADA, for the blockchain, for the code, it doesn't matter. They worth same. A smart contract doesn't care. It's like $1, $10, $100,000. Doesn't matter. It just cares that, okay, there is something was created here, and I consider this a token, it's valuable. There's a bunch of numbers you just created out of thin air. Yeah, basically. Like governments, with their inflation and stuff, like just print money. Like, yeah, this is the printing. So minting is an action of creating those monies, printing those monies, just making bunch of numbers. Like just probably if you are enough in the crypto, you have heard of many tokens, many coins. Like you've heard of Trump's tokens. I don't know, these celebrities tokens, some a scam, some not. Meme tokens, all these tokens. So someone just one day in a transaction printed that, minted that. So here is the place that if you built it, if you created, if just brought that to existence, here's the place that mentions or that says that here's the place. Yeah, yeah, you added these things to the blockchain. And now we have this bunch of tokens, 1 billion of something, your name token, whatever. So this is the place. And script data hash, I guess is this the integrity hash? I think. Well, probably, and I'm not
That,
sure.
that
Go
should be
ahead.
the hash of datum and redeemers.
Are you sure? Because, I have this issue. I mean, actually, I wanted to talk about that issue. So, I don't think this is it. Probably, I mean, I'm going to say probably. This is the hash of the transaction body, not the hash of the redeemer and datum. And why is that? Because of this damn error I was getting. You know, I can, of course, I can build this by hand or any tool. I can build this transaction. I can even change many things inside this transaction, right? Like changing the number, changing the slot times, or adding, removing, a bunch of data, right? And then encode that into this damn thing, Seaboard, and says that, hey, it is valid. Okay, but how a blockchain, how a node, how a program or tool can know this transaction body was untouched? It was the integrity of this transaction body to be tested. Again, we are using hash. And apparently this is the hash. So this is the hash of whole thing inside this object. And except, of course, well, it should be, it should be a stupid loop, but except this element, there is this body, and that body is going to be calculated. It should be a data, it's object, and that would be a hash. So here, for example, I have an error, and that error says that I have a transaction body, which is this guy, which you guys saw, and that transaction body, I mean, by the Apollo or by another tool, doesn't matter here, made a hash. It created the hash. But my error says that, dude, I mean, actually, I can show you in the wallet as well. Like, even the wallet didn't accept it. I just removed that valid shit. Anyway, I can show you. But it says that the hash I calculated, you see that computed script integrity is different. So I'm sorry, I cannot put your transaction into Cardano blockchain. It refused my transaction. Why? Because it says that your transaction is malformed. There is something wrong with the transaction. That hash you are just giving me, it doesn't match with the data. The data and the hash doesn't match. So yeah, I mean that's really a great security, of course, integrity of protecting blockchain. I think this actually was really a long issue and still is an issue wanted to talk about today, but well, Chris says don't. It's too much. But yeah, that I guess that's the hash, which has been currently provided a script integrity and computed a script integrity. So you can build a hash whatever you want, but it doesn't mean that it will be acceptable by blockchain or node. No, it must follow all these rules that we are just following. And if it doesn't, well, here's the example. It doesn't allow me to submit that transaction. But how did we get that hash is still a puzzle to me. Like it's just how did we calculate it? Uh, yes. Yeah, I just saw a Scott message that what is this command? This is the seaboard. Yeah, let me share this in the chat. And if you want to install Seaboard Diag, you need a Rust package manager for installing, which is what was the name of Cargo? Cargo? Yeah. So Cargo is again, I mean, you can install that, I mean, normally, but it is a Rust package manager, and by cargo, you can install Seaboard Yak. Um, I'm pretty sure there are, better tools that can go, but well, I didn't find it. I'm lazy to do it. But yeah, cargo install, then Seaboard Yak, and that Seaboard Yak after installing that Seaboard Yak is run like a command line tools, and then you can just and also you can build a Seaboard with this tool, but I just don't do it and just deserialize it. And I like the deserialization style, it's like a pretty style. Anyway, uh, so yeah, still this is confusing. The last things that I've heard from people in this calculation, we have cost model and other things as well. So it's not just really the transaction, but there are other stuff happening here. And if you are giving the bad information or wrong information or malformed information, yeah, we will end up with bad hash, bad transaction. Therefore, these error. Anyway, so yeah, and then we have non-empty set transaction input. So non-empty set. This is a transaction input. I don't know what exactly means. Non-empty set transaction input. Mm, is it a collateral? I guess. Yeah. I guess this is the collateral. So if you are, especially with a small contract, you see that function. Remember that I was talking about that function? In really, really rare cases, you can try to, build a function. I mean, that again, quote unquote, wallet that runs by code, which is bad. And by bad, I mean it consumes a lot of CPU, memory. It's a bad function. Although it returns true, it is executed successfully. Sorry, but it is a bad function. Let's not get into depth like what do we I mean by bad. Again, it's a rare case. It's really hard to do that and submit that. But if you do that, uh, you have to accompany your transaction with a collateral, with a guarantee. At least with 5 ADA, well, I mean, this was the rule, but now it can be any ADA. Anyway, the thing is, if your transaction try to do something fishy or bad or whatever, your collateral is going to be spent as a fine, as a punishment, kind of. We can say that uh, although it is really great that you successfully were able to make a rare case, but anyway, this is the place for saying that, hey, this is my collateral. It's not going to be spent if everything is okay. It's going to go back to your wallet. Let me see. Can we see here collateral? No, because, normal wallet to wallet doesn't need a collateral, because wallet to wallet, they're in a function. So absolutely everything is going to be okay and true. So that's the thing. But if there is a gap or something, like for example, I minted something, yeah, I minted, there should be a collateral somewhere. Uh, no, don't see it collateral. But yeah, especially with a small contract, you have to provide a collateral. And in your wallet, for example, you can set that collateral. You see that I have a bunch of collateral. Anyway, yeah, that's the whole idea of that. And here, that was the place. Require signer. In your body, you can say that, especially in a small contract, you can say that these people must sign. So in your witness, these people must be present. And how do we say there is this pub key hash, public hash of those, addresses, those wallets, this wallet. It consists of a public hash. Let me actually, maybe you can see it with Cardano. Scan. So here, address inspector. If I just put my address here. So yeah, this payment credential or pub key hash is the one that will be added to this body. Here we have two. So these two people must sign this transaction. Like right now we have one. Absolutely, this is the way, this is the rule. I mean, this is the things that the code, other tools, whether it's written in Golang, whatever is going to check. Did these two people sign this transaction, or are they part of this uh, witness set? And it is not just like two, like these, there are all sort of calculation, encryption, and all these things are related to each other. So again, you cannot just add whatever you want or modify that. This that's the idea. And then network ID 15. Do I have network ID? Well, I don't have network ID here for some reason. Maybe we could add it. Network ID, well, let me show you. We have several blockchains. What I'm right now showing you is the testnet or preprod. In Eternal Wallet, you can see like we have mainnet, the official Cardano network launched by IOG in 2017. But we have other blockchain as well. There are people running the stuff here. It's valid. It's a kind of replicated. I can say one-to-one, at least the purport of the mainnets. Why do we do that? Well, as we said, it's just testing stuff, or, like not playing with the real money, real value. If you do stuff, crazy stuff with your wallet, or if you lose something, well, so be it. You don't lose something. We have also preview tested. The difference is their epoch. Remember that day? It's shorter. So in the mainnet and in pre-prod, that epoch each 5 days, I mean normal 5 days, will be one epoch. But here in preview, it's just one day, one epoch, really faster. Why? Because, well, if you want to have faster report, like imagine you want to test, I don't know, something about trees, animal or whatever. If you have this clock that's make times faster, sure, you can see many things. So yeah, that's all idea. And of course, you can run your private network. And also, we have other networks here, it's like for, on-chain governance, on-chain. But you can have also your private network and make things much, much more faster. Like each epoch, I don't know, 1 minute or something. So yeah, I mean, you have all this ability. And for some reason, you are able to put that ID here. The transaction output 16. Well, we don't have output. We have output here, but why do we have again two outputs? Two is the coin, here is the transaction output. What does that mean, guys? Like, why the transaction output? What happened? Sorry. Uh, why transaction output? We have two. We have transaction output. I don't know, to be honest. Maybe it's something from old times. Uh, but this coin here, which we call it coin, is the place for transaction output. Like this is, you can see these are the outputs, like the UTXO, the new UTXOs. And then 16. Here I don't have a 16. Interesting. I don't know if anyone knows. Love to know. Coin. Let me see. I don't have even, again, the coin either. Non-empty set transaction input 18. So 18. I bet this is the reference input, right? Am I right, Adrian? I think this is the reference input.
I don't know.
So what do I mean by
Can you go
reference input?
back to the CDL, CDDL?
So reference input, or
Is
what we
that maybe explained below somewhere?
it is a witness, transaction output, metadata.
If you scroll up a little bit, there is no, that's input.
If I remember correctly, this is the reference input. So guys, with reference input, I mean read-only UTXO. See that this collateral, as I said, like it's not going to be a spam if your transaction is okay. So we have other transaction, we have other, sorry, UTXO, we have other UTXO which can be part of the transaction, but not necessarily being spent. They are going to be there for the sake of using their data, their value, whatever they are carrying, whatever was attached to them. So that would be this is the place, if I remember that correctly. So we have this idea of, you can have your smart contract on the blockchain. This is the place. If I remember correctly, this is the place for read-only UTXOs. The UTXOs which come to the transaction, especially for a smart contract, to be used uh, as a data provider. So they are not coming for to be spent, to be consumed, just data provider. So if you guys have heard of oracles, oracles are projects or um, these tools that provide data outside or real data, real world data to blockchain. Here is the place that we put these Oracle UTXO, Oracle data here. Voting procedures are, of course, proposal, obviously related to governance. Uh, let's not talk about coin. 21 is again coin, although 17 was coin. No idea. 21 is coin. Do we have something here? No. Unfortunately, no idea. I have positive coin. No idea either. But let's try to find out. Can we get any idea something somewhere here? Witness, bounty redeemers, orange, no method relation between value, votes, voter, voting procedure, invalid before, invalid hereafter. We see that you remember that those slot number. I mean, invalid before means that issue day. Invalid hereafter means that expiration day or date, something like that. But it's actually beyond that, more than that. It's not like a simple issue date. It's not like a simple expiration date. I mean, it's really beyond that. But I just want to help you to find that, that period. That okay, there is a period of time. How do we show this period of time based on these two? But we can set if you add transaction word before these two, it might make more sense. The transaction is invalid before, the transaction is invalid here and after here, like after now. If you want to explain that, it's just what. Uh, in the programming, we don't like to explain that much. We want to stay mysterious, you know. Anyway, uh, DNS name, again, related to the node stuff, parameter change action, pool proms, it's related to pools, stake pools, etc. Um, Transaction update committee. These are again governance. That's all. Congratulations that we don't have more explanation. Very great of IOG. The relation between numerator and denominator can be explicitly, but we have a limitation currently. Which for the product testing, we need to be able to generate random value for testing. So, yep. Sorry, back here we can
Yeah,
see.
and maybe if you look in the other CDDL files,
Let's
because
go. Yeah, sure. Maybe
HK
let's go to
normally does not
other.
explain things twice.
Maybe going to the kind of the beginnings. Let's go to Shelley. I think the Shelley was the beginning. So we have formal design spec and we have NPL. Let's go for the CDDL. Who does CDDL? CDDL test ledger. No, let's go to CDDL. Shelley CDDL. That's kind of similar so far, but let's find the transaction body. I think no. Transaction body. You see that kind of several era before quote unquote major release, like release of like all release of Cardano transaction, but it was really small. But now it's bigger, right? Like you can just see, wow, many stuff here. So we don't have 18 here even. Uh, Take care, Scott. So let's go back to the Uh, when did we have Byron Babbage or Alonso? Brutus version. No. Babbage was, I think, the. Let me see. What is this? Syntax. Oh, I think. Oh, okay. CDL of Babbage. Let's go down to transaction body. Okay, protocols. Redeemer. 18. Let me search for 18 to be honest. 18 cost model for a script language. This is protocol parameter cost model. Is this protocol parameter again? I think it talks about protocol parameters. We can see here. Reference input. Yep. So they have explained this better. Okay, thank you very much. This is the comment probably. So as we, if I was right, like collateral inputs was 13, collateral returns and total collateral. Interesting. So we can say like here, we can say like we don't have it, but imagine that we don't have enough collateral, like 5 UTXOs. Each consists of 1 ADA, or 2 ADA, or whatever. The collateral is big. And then that should go back to somewhere.
Mix isn't collateral, just one UTXO. Did I
But it is
have to?
inputs.
Oh yeah, then you're right.
I think here they've changed it. I mean, they introduced it that it can be several, and then it should go back to a wallet or whoever return, and
The
then
reason
total.
for that is mixed that you can now have inputs which have, let's say you have 100 ADA UTXO as input, as collateral input, then you can define a return so that only the 5 ADA or whatever the collateral would be is gone and not the whole 100 ADA.
But one question, again, do you remember that can we use one UTXO as input and as collateral at the same time?
With Cardano CLI, yes, but the most transaction builders don't allow that.
Okay, I see. So yeah, we saw a bunch of explanation. This is the reference input, aka read-only UTXO. Uh, Update, withdraw, units, mint. So somewhere probably we have more information about script data hash as well. I wonder this. But does anyone have any question? Any comments, anything that they want? Actually, I want to, if you- I wanted to look into,
And I'm just checking the time. We should wrap up in the next couple.
yeah, sorry. So we look into the transaction. We look into the what is the CBOR. A CBOR is just a bunch of, it's a binary representation. Like it is just encoded a string of numbers and letters of bigger things, an object or a list of object, which we can see, based on this bracket. It is a list, and inside the bracket we have bunch of curly bracket, hence objects or several, and that is going to be converted to CBOR. And here we can see that there is this RFC, there is this internet standard for explanation of that object representation in a human readable or data definition. Though that we just saw that, sure, it is great, but well, it's not really explanatory or that much explanation. Still, we have to look into previous documents, other stuff, but I wish we had, comments more. These are comments, I think. These starting with dot column is it means comments. But anyway, well, we have always comment issues with the developer. So yeah, and then this is the transaction body. We just look at it, and then we look into stuff more in details here. And this transaction can be built by many tools, including Apollo, which I was building. Like, maybe one day we can look into it. This is the code example of that building transaction with Apollo. And then we didn't touch something that I wish we could touch. And that was, well, we didn't look into really to blocks, although blocks would be a place for all these transactions, all those CBOR, compact into one package in one box. Sure, hopefully we can look into it. And then I wish we could look into what are the production ready tools at our disposal. Um, yeah, that's it. Any question? I hope it was a helpful session. I don't know. What do you think, Chris? Was it was it a good session or not? Chris? Uh, Chris?
I think we're
Mm,
getting there. Yeah.
yeah,
Goals for making it more interactive and actually building some stuff together. I think
yep,
we're like reviewing documentation, code review, that kind of thing. Let's try to build something meaningful with a production library over the next couple
yeah.
sessions.
And unfortunately, I think I won't be available next week. I'm not sure, but probably in high probability. So I wonder that can you handle the meeting, James, or should we,
Keep me
you know?
posted. Let's maybe we take a week off then and we align on why we're here, right? My
Okay.
understanding of why we're starting these sessions is to help people A, get ready to actually be writing code in Go to do things. And B, we had the vested interest in preparing people to work on both the Apollo and Handshake projects. So really thinking about the course. I'd like to think about what lessons do we have to write to prepare people for the things that actually got us to do this session in the first place. Because I'm not sure we're growing yet. We are having a good time reading through docs, but I don't feel like we're creating
Yep.
learner facing resources yet. And that's not, I can't take that on for next week alone. So maybe we pick it up in 2 weeks and set a goal mix when you do have time of you and I can see
Yep.
how the course outline looks and propose that to everybody.
Sure. Yeah.
Okay. Let's try that. All right. So we'll pick up this in 2 weeks. We'll remove it from the calendar for next week and we'll put the announcement out there. And we'll get going again. What will that be? April 8th or 10th? I can look at the calendar.
But thank you,
Everybody.
everyone.
Yep. See you
Great
soon.
to be here and great to talk with you all. Take care.
Cheers.
Goodbye.